Oh, okay, teacher have already started recording. Alright, so let's just get straight to our presentation today. Can you guys see the slide?
Yes.
Okay. Then you can start from the first person. Yiru.
Can you hear my voice?
Yes.
Okay. I think if Leighton Yu help me to control the PPT, if it's okay.
Yes.
Okay. Hello everyone. My name is Xu Yiru, and you just call me by Selena if you have any questions. Okay. We're introducing the artificial intelligence today, and I'll introduce what is data science. Data science is an interdisciplinary field that combines statistics, mathematics, computer science, and domain expertise. It involves the process of tracing valuable information, insights, and knowledge from structured and unstructured data. And data science, the scientists use a variety of techniques and tools to collect and process, analyze, interpret large amounts of data to discover patterns, extract meaningful information, and make data-based decisions. They typically possess mathematical and statistical modeling skills and are able to apply machine learning and artificial intelligence techniques to solve real-world problems. And the main goal of data science is to extract value from data and use these insights to guide business strategies, make predictions, and optimize decisions. Data science has a wide range of applications across industries and domains, including finance, healthcare, and retail, transportation, cybersecurity, and more. Okay, the basic steps of data science include number one, data collection. It collects structured and unstructured data from various sources. And number two is data cleaning and pre-processing. Handle missing values, outliers, and inconsistencies in the data and convert it into an analyzable format. Number three is data exploration and visualization. It understands the statistical properties and correlations of data through exploratory data analysis methods. And number four is data modeling and algorithm application. It applies statistical methods, machine learning and deep learning algorithms to model data to discover hidden patterns and perform tasks such as prediction and classification. And number five is results interpretation and visualization. Interpret model results and insights and present them into an understandable way to non-technical people. And the last one is model validation and optimization. Evaluate the performance of the model, conduct model optimization and improvement to improve the accuracy and reliability of predictions. So, in summary, data science aims to uncover value and insights in data through the application of data analysis and related technologies, thereby helping organizations to make smarter decisions, improve business process, and provide innovative solutions too. Okay, help me to change to the next page. Thank you. There are supervised learning uses labeled data to train the model. Imagine a teacher guiding the students and telling him the answer to each question. As the student asks more and more questions, his understanding of this type of question will be more and more. It will be more and more, and the deeper it is, the higher and the accuracy will be. A fully labeled data set means that the data received by the machine learning model has input and output. Therefore, assuming that an image recognition model is to be established to distinguish the 10 numbers from 0 to 9, then the model will receive a bunch of pictures of numbers. That is what input is. And the numbers of these pictures are output, are what I say output. And in the real world, supervised learning is the most frequently used by the industry, not only because the huge amount of data in the world today, but also because the simplicity of its algorithms. For example, the team can train the model from the customer's consumption history and build a recommendation system to marketing personalization and automation. The common algorithms and their commercial applications are what I'm going to introduce you. There are 8. And number 1 is linear regression. Linear regression is the most primitive machine learning model, and it is also the most common model in finding the relationship between independent and dependent things. And linear regressions can not only help business owners establish consumer insights and understand factors that affect profitability. Regression analysis can also allow business owners to evaluate market trends and use it as a benchmark to make business decisions. And number 2 is logistic regression. Similar to linear regression, it also finds the relationship between independent variabilities and dependent too. However, unlike linear regression, the output of logistic regression is binary, either 1 or 0. And number 3 is naive Bayes, a machine learning classification algorithm based on the theorem that calculates the probability of an event based on the influence of other factors. Number 4 is the decision tree. The decision tree uses the values of different data characteristics to divide into different branches, like branches on a tree. just like when a bank decides whether to lend a loan to a certain customer, the bank staff will judge the final decision through a series of questions. Using the same architecture, decision tree keep splitting features of data until continuing the branch off provides no value. Number 5 is random forest. Random forest uses multiple different decision trees and gives each different decision tree its classification options and allows each decision tree to generate its own answer to improve accuracy. And number 6 is support vector machine. It also, you can call it SVM. It's mostly used to in classification. However, its characteristics allow it to be converted into regression. Constructing a plane or hyperplane set in a high-dimensional space, assuming that it is two-dimensional. SVM can find the most suitable line to distinguish the input value according to the output value. And number 7 is adaptive boosting. By a variety of different models to do classification or regression analysis, and finally judge the proportion of each different output according to its correct rate. The adaptive boosting and other boosting methods are very effective to improve accuracy. Number 8 is the last one. It is GDP-BT. Is gradient boosting trees can sequentially generate decision trees and let each decision tree focus on repairing the mistakes made by the previous trees. And its output is the combine of all decision trees. For data with very clear main data characteristics, the industry can use feature engineering to arrange the most relative data characteristics and use them for training. Okay, that's it.
Okay, hello. Can you hear my voice?
Yes.
Okay, 好。
Sorry, 那个灯宇 could you enlarge the slide to a full screen? You control this slide, right?
Okay, let me see if we can do this.
查看
右上角那边有个投影播放。
Oh, I see.
Okay, thank you.
So next, I will talk about the unsupervised learning. Okay, please turn to the next picture. Okay, unsupervised learning is a machine learning model that doesn't include human judgment in the data, and it usually used when there is no access human to interpret the data or when the data cannot be interpreted because of the lack of the basic ethic. And unsupervised learning, it doesn't require label data, and label data is indicator data which doesn't need human judgment. Okay, next. Unsupervised learning is only related to the input data and no requirement for target. So in this picture, we can see we will input the data and through the unsupervised learning and then output. So the data in this unsupervised learning, he have a large amount of the unlabeled information. And unsupervised learning is unlike the supervised learning, where you have to provide input data and request the target data. Unsupervised learning is standard for itself, and it will be adjusted according to the result. And next. unsupervised learning is similar like cluster algorithm. So in left picture, we can see there have many data, and it will according to the human's appearance, like weight and his height, to divide them into the different groups. And in right picture, we can see it can be divided into three groups, and every group we can see this in center have the store plot. This store plot is every group's center. So it will calculate and categorize based on the number of the grouping we enter. And according to this principle, we can cluster them when it doesn't have desired output. Next. This is will compare the unsupervised learning and supervised learning. And first, we watch the supervised learning. Supervised learning is like guiding learning method, and it have the correct answer and use the information with the answer during training, and it will usually use to classification, and classification is determined by its label, and unsupervised learning is unguided learning method. It's like you study by yourself, and unsupervised learning doesn't have a correct answer, and it use the information with no answer during training, and it usually to start grouping. Next. This picture is about the supervised learning. In supervised learning, we have to talk about the model. This is an apple, and when we input the data through the model, and the result will talk to us whether it is the apple. So when we input data is the apple, and the result is it is an apple. But if we put the input data is banana, so the result maybe it will come out it isn't an apple. Next. This is unsupervised learning. Input data have many different appearance or many different kind things. And through the model, it will calculate and compare each other and grouping by the model by itself. Next. And unsupervised learning have three different kind to cluster. First is the K-mean, and second is HAC, hierarchical agglomerative clustering. And third is the DBSCAN, density-based spatial clustering of application with noise. Next. And the example in the unsupervised learning first is the advertisement placement. User will be segmented by gender, age, geography, location, and other dimension, and can also be categorized by user behavior. So with many dimension of user segment, advertise can be more target and more effective. Next. And second example is recommending system. It will suggest some related product based on your browsing behavior. So that picture is the online shopping. It will according to what you buying before or what you browsing. The app will recommend something maybe you will buying. And the right picture is about the YouTube. When you watch this video, the right list, maybe it will recommend some video related to this video while you watch. Okay.
Okay, can you hear me?
Yes.
Okay. And it's my turn to introduce you the reinforcement learning. Okay. As mentioned before, we have already talked about supervised learning and unsupervised learning. Supervised learning is when you give the computer something and he will tell you what it is. And unsupervised learning is you give computer something and it will classify into some subgroups. For example, I give computer a banana and he will tells me it's a yellow thing. Okay, but what if we encounter some much more complicated question, like if I want to go to the Lawson from Okayama University, how do I get there? If I ask computer this question, computer can't answer this question by using supervised learning or unsupervised learning. One of the way to answer this question is to count all the routes we can go to the Lawson. But it's kind of stupid because if when we encounter a much more complicated question, then choosing a route, it won't work. So here's the reinforcement learning do. Let's take playing Mario for example. There's 4 steps of reinforcement learning. First, we put the artificial intelligence in the environment, and the AI will do the first step. It's called observation. He will see what is going on in this environment. For example, in the photos, you can see, oh, Mario is stand on some of the bricks, and he will go to the second steps is decision making. Then the AI will think, oh, so when the Mario is standing on the bricks, what can Mario do now? He can move forward, move backward, jump, or duck down. So if the Mario go the one of the decision, if he go forward, then he may have some something happen. Then it comes to the third steps of the reinforcement learning is feedback. If the Mario go forward and he encounters the enemies, then he died and the game is over. Then the feedback will be a negative feedback. And at this time, AI will know, okay, at this circumstance, I cannot make the decision of going forward. But if he touch the superstar and get more points, he will get a feedback. Oh, when in this second circumstance, I go forward, then I will get more points. So the positive feedback will be learned by the AI. Then this is the 4th step is learning. And it will become a circle. The AI keep observing the environment and thinking about what to do now, and try every possibility that he can do, and he will get the feedback from the environment, and he will know, oh, in what circumstance doing what steps will cause positive feedback or negative feedback. So in the reinforcement learning, the most difficult step is feedback, because you have to know what is the positive feedback, what is negative feedback, and you have to make the AI functioning to classifying what is positive, what is negative, so the circle would be go normally. Okay, the application of enforcement learning you mostly might be the AlphaGo. The AI in AlphaGo, he observed what is going on in the play. Like you see, there are many black and white dots, and he will observe. Okay, if the disable is in a period circumstance, or he's going to lose, and he will decide where to put his goals. And the other example you often see is the autopilot system. The AI will observe the road and the cars on the road and decide the car to turn left or turn right or to escape the man is walking. And this is the brief introduction of reinforcement learning.
Hello, can you hear me?
Yes.
Okay. And next, hello, my name is Chanel, and next I will introduce some deep learning. Next page, thank you. When everyone hears about deep learning, the equal is with artificial intelligence. In fact, both machine learning and deep learning are important theories in the field of artificial intelligence. And deep learning is a subfield of machine learning that focuses on processing and solving various complex tasks using multi-layer neural networks like the human nerve system. This method is popular for its excellent performance in processing large amounts of data and complex pattern recognition. Next page. Thank you. Next, I will introduce some important concepts and components of deep learning. First, neuron, the basic unit of neural network. Each neuron receives input from other neurons, performs a weighted sum, and converts it into an output through an activation function. Second, neural network. It consists of multi-interconnected neuron layers. The first layer is the input layer, the last layer is the output layer, and the middle layer is called the hidden layer. Third, activation function. It is used to introduce nonlinear characteristics into the neural network. Common activation functions include like sigmoid, ReLU, and TEF. Forward propagation. The input data is calculated through the neural network and passed layer by layer until the final prediction result is obtained. Next page. Hello. Next page. No, it's too. Last page. Yes, thank you. And next is backpropagation. It is a method of training the neural network by calculating the error between the predicted result and the actual result, and then updating the weight of network according to this error to minimize the error. Loss function is used to measure the difference between the predicted result and the actual result, reflecting the prediction accuracy of the model. Finally, gradient descent is a kind of optimization algorithm used to update the neural network, weighted to minimize the loss function. Next page. And the basic concept of deep learning is the use of layered abstract ideas, and it is believed that higher-level concepts can be learned from low-level concepts. So the number of hidden layers is increased between the input layer and the output layer. When the number of layers increases, the network looks deeper, so it is called deep learning. Next page. The main feature of deep learning is its ability to automatically learning representation levels, which means that neural network can learn high-level abstraction features from raw data without manual supervising features. Through multiple hidden layers, the neural network can build a hierarchical feature extraction mechanism, which make it perform well when dealing with complex problems. Deep learning has achieved breakthrough in many fields, including computer vision, like image classification, object detection. Second, natural language processing, like language translations, sentiment analysis, and speech recognition, among others. It is being widely used in the area of big data and has achieved remarkable results in various fields. Thank you.
Okay, so we have already introduced you data science, supervised learning, unsupervised learning, enforcement learning, and deep learning. And these are several learnings that we most use and see on AI. And in fact, a system can be built in only one of these methods. They are used together to build a system, for example, a autopilot system or whatever. And the task we are going to do is to think about how can we apply all these different kinds of learning to help us to use on, for example, medication, on the medic systems. Yes, and here's our presentation. And if you have and guys have any questions. Okay, so if you don't have any questions, the next thing we are going to do is I will open a vote in a group later on to decide the next meeting day. This is the first thing. And the second thing is I would like to ask you, because we have already confirmed our topic is lung cancer. And before we go into the topics, I think we need to know the lung cancer, what is going on in the lung cancer. So I would like to ask you if you would like to separate into 3 groups, and one of every groups introduce a part of the lung cancer. For example, one of the groups can introduce the physiology of respiratory system, and the second group can introduce the physiology of lung cancer, and the third groups introduce the treatment and medication of lung cancer.
I think that will be okay.
Okay, so Give me a second. I type it into the chat room. Can you see? I type in the chat room. There's 3 parts, and there's 7 people in our group. How about let's separate into 2 and 2 and 3?
Okay.
And for convenience, 2 Taiwan, and 3 Japanese classmates. Will it be okay?
Yes.
Okay, then okay, I see Koga-san thumbs up. Okay, it would be great. And I will put it in a group and you can, okay, Xiaohan raise the hand if you have any questions.
No, I don't have any questions.
Okay. Okay, accidentally raise the hand. Okay, and I will put it on a group and you can pick up which the part of lung cancer you're going to introduce later. And so the next meeting, we're going to introduce these 3 parts of lung cancer. Then after the next meeting, we're going to go into the topics. Would it be okay?
Yes.
Okay, so if you guys have any other questions about artificial intelligence or any other questions about the disease, you can ask in the groups. Feel free to ask in the group because artificial intelligence is kind of complicated and it takes time to get a little bit understand to it. So don't worry about it, and we will take into it step by step. All right. And
Okay.
if there is nothing else, oh sorry, teacher, do you have anything to remind us?
No, but I have some comment. So
Okay.
firstly, I would like to thank our CGU student for this good AI presentation for OU students. And in this presentation, they also give a very interesting example to application of AI for OU student. And I believe, although the maybe this 40 minutes presentation cannot let you fully understand of the concept of AI, but don't worry. So for all you students, the teacher, I will also give you some information of the application of AI for lung cancer. So and also we have a very good leader, Deng Yu. So I believe we have let's work together to make the presentation better and better. So thank you.
Okay. Thanks for teacher's comment. And yes. So I will open a vote for the next meeting date, and I will let you guys choose the part of lung cancer you're going to presentation next meeting. And this is all of the meeting today. Any other questions? Okay, I see no questions. If you don't have question now, it's okay. You can ask. Feel free to ask in the group later on. And if there is no other things to do, then Here is our meeting today, and goodbye.
Bye bye, everyone.
Okay, goodbye everyone. And Daniel, can you stay here? I have something to talk with you.
Okay.